just go through the last part of the section is for Q&A. So you can read in the chat there or mute yourself if you want. So today I bring to Swift Essentials that we will talk about actors and concurrency because it's getting like something very important nowadays for everything, every mobile developer, especially in iOS, to understand how actors and concurrency works behind. So this will be just a overview of this concept. So first of all, we want to talk about how concurrency works, about Swift tools to handle concurrency tasks. Finally, we want to meet actors and some code examples. And if you have time, Q&As. So first of all, I will introduce myself, keep key facts about me. I'm software developer, like working more than 10 years and only 3 years focused on iOS developer. I want to master this craft because I like a lot iOS developer. I'm working on Verbo Owner app at Expedia Group. So I'm very proud of this project because it's a top tier app in the world against like big competitors, Airbnb. And in my free time, I enjoy play football, do boxing, and also play music as a DJ. So, in context to Swift, in 2021, they introduced engineers of Apple introduced this Swift concurrency concept. Especially, we will now concentrate focus on async and await tasks and actors in this talk. But from that point to now, they do a lot of improvements to work on data arrays specifically. So they introduce sendable and other isolation, full data isolation concepts to handle this concurrency task. So this is the way, the old way to write code with functions that are asynchronous, to handle with completion handlers. So you can see it's like very with a lot of line of code to express some to work with this concept. And in a single way, they simplify this concept to the same function you can write in like 4 lines of codes or even less. uh, because it's very straightforward with a thing you only need to understand that this function will be asynchronous and you will get a result. And this result can be an error, for example. So yeah, I put this name like the future is now because we will like we continue with see concept that dispatch like queues and all these functions in our codes, but soon or later the all we were writing in async and await way, like it's in a more cleaner way than our code. So what is concurrency? Sorry, I don't know how to hide this because I don't have the mouse here. Or, well, I don't know if you see the full title. What is concurrency? We have two main categories. Like in our apps, everything is asynchronous or or synchronous. So this task in like is very well known that for everyone when we run an event, this event will be located in some point of the memory with the function, the variable that we need to trigger this event. So the processor will save this memory and will run in a thread. This thread will be the main thread. The main thread is like the principal one that the user can interact with our product, with our app. So also it's called the UI thread. And so asynchronous is when you trigger this event and the event will be execute another event, for example, download an image. And this event, when this finishes, will resume our UI. So this synchronous process will like every event need to wait or will start after the previous event finished. So if the one of this event takes longer time, you will be experienced like a freezing in your app, like you cannot do anything. So this concept, they introduce engineers, of course, asynchronous because we want to do more things in our apps, and as we know. So in this main thread will need to be released. So we create another thread to trigger this event, like processing images to load images, and we can still be doing scrolling or trigger other events. So each events will be happening at the same time, and this is called concurrent task. So when we talk about concurrency, is not like events are running in parallel, are running at the same period of time. Concurrency is when more than one task are running at the same time. So this is are like the simple concepts. In processor, for example, CPU is a central process unit. A CPU can only run one event at a time in one thread. So it's like if you have 8 cores, like 8 processors, you can do 8 tasks at the same time. But for example, other kind of processor like GPU, that they can run create multiple cores because they need to run like multiple events at the same time. For example, in gaming or processing like machine learning, for example, the result they need to create parallelism, like run multiple events, so they create multiple processors. This is the big difference of both. We can focus more on CPU now. So behind the processor, in the old way, they create like the processor can run just one event. So they create more threads every time that we need to, any threads that we need to use. If you have memory to create more threads, the processor will create more threads. And so you can see like in this example, the processor run in orange, run the event, and create another thread to execute the next event in background, and we'll be switching between the threads multiple times very fast, creating the illusion of parallelism. But actually, they are running just in concurrent time, but switching context. So this concept is called switching context when the processor are switching context between threads to run these different events. Until each event is blocked, they will switch to another. Um, so this create a lot of memory, and they need a lot of overheat processors. Like the processor need to allocate not only the memory of each thread, also the switch context execution. So it's a lot of memory, and this is not efficient. So engineers create so concurrency to be more efficient, and they create this concept of continuation. So each processor, like obviously they can run only one event, so they create just one thread in each processor. The processor just handle now functions, and these functions are continuations. So if the function need to be suspended or blocked, they will be uh, allocated in other threads they call pull thread or blocked continuations. So the memory will be located there, and if the processor need to run another function, they will switch to another continuation. And so it's less switch context between threads. You don't have like any threads. So the system will handle how many threads they need behind, but the processor will be like very straightforward. This is the more efficient way that Apple says. So engineers are focused are putting a lot of effort in this, and they are continuing working on this part. So if you are more interested in this concept, there is a good talk about Swift concurrency behind the scenes. They explain more in details how the stacks and memory works in behind. So it's good if you want to get deeper in that. But now, so we need to understand how is the difference because of parallel execution, concurrent execute, queues, and serial queues. So if you see this diagram in the middle, is marked like concurrent execution because this is the essential of this. Like concurrency is when multiple events are running at the same time, not parallelism. So I mentioned before data races very briefly. So what is data races? The description is that data race is when two or more threads are accessing the same memory location when at least one of them is writing. So in these threads, um, like if one event or like two events want to read and one of them want to write in the same memory location, something rare will happen. So this is a data race because you need to change this data or read it first. And this happens a lot in our apps. We need to handle this. So concept, basically, Apple says that concurrency is threads allow the execution of code at the same times. So events are running at the same times, the threads. CPU cores each can each execute a single thread at any given time. So yeah, basically it can just run one task at a time. And maintaining code invariants is more difficult with concurrency. So this is a problem because if you have all this tool to run our work with concurrency, but we have this problem with like how to manage these data races. Um, so I think a way we need to understand that it's just a way to write our code in a cleanest way, like with functions that I think is like your function will be asynchronous, and this function will need to be suspension, like a wait, marked as a wait because it's a marks a suspension point, and they will be a result. And all these tasks, this function need to be running in a task. Task is the most simple piece of this Swift concurrency tools. So it's given the context to run our functions in a synchronous way. So now we have been talking about threads. I mentioned processing and memory. I think we can now meet actors. Um, so this is the simple structure of an actor. The actor is very similar to a class. We contain function variables. In another view, we can see like actors are reference type, similar to a class. Everything here is isolated by default. That means that everything here need to be accessing by one event each time. So everything is synchronous in this context of actor. But actor doesn't support inheritance. So yeah, this is important to understand. Like everything is async. An actor should be explicit, not isolated, if you want, because they are isolated. So this table is like to fully understand like the difference between struct, class, and actors. Uh, the actors are reference types, similar to a class. Both are located in the heap memory location because are data that need to be mutable. So they need to be stored in some point, and for that we need initialization. Like we need to create this part of in the memory, like initialization is required, and similar to a class. Does not support inheritance, and actors in are, are thread safe, so are creating for working concurrency. Is the and so uses cases like strat are simple objects, class are objects like complex objects like mutable data, and actor are focused on concurrent programming with multiple data. So now I can show you a little piece of code. I have a challenge actually, but I'm not sure about how many of you understand all this concept, but I will left here. But first, I will write some actor simple actor like okay, I will we follow the more easy to follow this autocomplete because the structure of this that I want to show some interest point here, like okay, a function. Yeah, if we want to call, this is the simplest structure of an actor. Like we have variables and a counter, and we want to like update this counter. And if we want to use this, of course, we need to create an instance of it. And this need to run a task context because the task context give us the, the space to handle like asynchronous tasks. So in this way, uh, we have like, if we want to call, for example, a print, we want to print the counter name. The interest part here, like this is a constant, so never will change this value. So they can interfere like when it's a constant, it's like never will change. So this will be immutable, and you can access like in a in synchronous way. Not we don't need to be in a sync way in a sync. For example, sample actor counter counter name. If I change this to variable, uh, the code should suggest like yeah the expression is async because internal actor everything is async like so you need to mark with await. So even if you want to read a variable, you need to always access to it like in a wait context. If you have questions, just write in the code in the chat and we'll see next. So this is important thing because if you want to like here is isolated, and if you want to mark like we want to work with code in synchronous way, we need to mark like this non-isolated way. With this mark, we are telling our code that, okay, you can access to this in a sync way, synchronous. We don't need to use a wait. But now the Xcode will say, hey, you cannot do it because this is mutable store. So because actors are created for this purpose. Like if you want to create variables and you want to accept them, like you want to change the value, like here, for example, if I call this print and I see I want to change the value counter and I want to, yeah, okay. um, uh, Okay, what is the scope? Find the content. Yeah, because I don't call in the. Yeah, it's smart. Yeah, the auto completion like anything after we don't want to say after. Okay, the other thing that the function that don't need to be marked as a sync because everything here is a sync, so we can just omit this and the code will be like okay because everything here is a sync. So the auto completion, yeah, like they mark very, but yeah. So this is the most simple concept about actors. Everything is async. If you want to access it to it, you can access in synchronous way. Asynchronous way, everything will be asynchronous. If you want to be like in synchronous way, we don't want to await something. We can mark in non-isolated, and this will be fine. But yeah, in this part we are calling this part of the code like is a variable a mutable object. So we need to like only we can work with a synchronous or like we can work with synchronous function if we are calling like not mutable data. So this is like very safe in Swift. Give us this tool to work with this in a safe context. And I don't know if this mark is happening in previous version because I have the latest one. Maybe now in Swift 6 they are more strict with this because they improve a lot of this in data races. So probably in previous version we don't have these warnings. So yeah. I want to see if you want to add something, you have questions because, okay,
No questions in the chat.
okay. So, for example, why to use actors? Basically is to ensure like that only one task can access to multiple state at the time. Would use is to prevent redundant API calls because we can create an actor like a manager to handle or queues to trigger our calls. So every time that we call this queue of manager that trigger our calls to the API will be running in one at a time. So we can avoid like redundant like if you want to download images and you are running multiple times the same process again, you can see in the code like you are triggered the same call multiple times. You can avoid with actors and yeah, help us with data races. So to avoid unpredictable behavior in our apps, because these errors are very hard to trace if you have errors with bad handling in code in like the queues and you are not using like in a good way semaphores or logs in the previous one, you can expect very strange errors, and the trace of these errors are very hard to find. So that is why Apple engineers are very focused on this part of the solution and create those actors and everything. So that's it. About the challenge is if anyone can interfere, um, if you understand what a mine actor are, like in this will what point will be triggering the main thread or in the background thread? Like everything will be running in the main thread or not?
Guys, don't be shy.
Anyone wants to solve it? Means that this function will be a start in main thread. Okay, main actor is a mark for our code that this function will start in main thread. Then we create a task like another, but this task will be running in main thread or not. And then we call another function. This is await. So this async function will be running in the main thread, which the 3 points are all running in the main thread or not. This task should unblock the main thread.
Yeah.
Yeah, but this task will be a start in which thread? In main thread, or in this point, if I put a print here, print.
Yes, it should.
This print
should run in the main.
In the main thread, and this, what will happen?
Maybe this one will not be on the main thread, some other task.
Sorry, this some other task, yeah, will be running in the main thread.
I think it will not run in the main thread.
Yes, exactly. Yeah, the tricky part is actually this, because here we are marked this function like this will start in the main thread, and then task is, you can see like if the Apple says that the task is like by default in the background thread, but task inheritance the context of they are running. So first, like if this run in the main thread and task is running start in the main thread, both will be running in the main thread. So this will happen in the main thread, and then they create this suspension point, and this will be running in any thread. Like this function will be starting any thread because this is a wait. So this suspension point will create another thread to run this second task. This will.
Sorry for interrupting you. Could it be like predicted which thread the some other task func will be executed on? Like, do we exactly know that this would be executed on some background thread with some specific quality of service label, or this is like left for Swift internal implementation and we cannot rely on that, that our knowledge of the thread on this will be executed will be 100% correct at every point of time?
Like how can we sure like every time that this will be running on this thread?
Yes, which thread? Could we like predict? Can we know whether this is on a specific thread or just like left for the Swift internal implementation decision?
Yeah, in task we can give like priority. We can also add here like specifically this will be running in main actor, for example. But if not, Swift concurrency, like that is Apple suggests, like Swift concurrency is created like they efficiently handle this thread. So we only give like the suspension point, like my function will be async, and you can handle this in efficient way, like switching context behind and all that stuff. But our task can be, we can explicit like this will be running in a main thread. Also, we have priority. So if you can create a task priority, if this you can create a queue like in low priority or high priority to run this task also. If you want to start one task first or no. That answered your question, Andrew?
Yes,
Andrew?
thank you.
For example, the about reentrancy, because if you have time, because the one problem that these engineers detect, like actors are isolated, but what if two actors are creating some suspicious point, like they're waiting here, like if you create like an await here, so when the actor will be running, this function will be waiting for this internal process, and other tasks can execute the same actor, the same function. So there are two waiting points, suspicious point, and one of them maybe will be like, again, will be happen these data races. So they create a function, is called continuation, to create to create a safe context. This function, is basically is a function that will be waiting. Instead of create this waiting inside, you will recreate like everything that you want. So when this function will be triggered from other tasks, like two tasks will be try to access to this function, they will be like doing this continuation. So internal they will handle this when they need to wait for the other function to start. So they create this safe, like data array safe in actors, because a lot of problems they start like if one actor can access to another instance for other objects that are not actors. So, but I think this is another scope, more deeper in more problem with data array safety. But I want to introduce you to this concept because are very essential nowadays in Swift. So, yeah, thank you everyone for listening.